What we're working on today is section 8.3. We have already learned about similar figures. Similar figures, I remember when one is larger than the other and they have proportional sides and equal angles. Last lesson we learned that you only needed two sets of equal angles for them to be similar. Today we're going to learn about side, 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 which is what it sounds like. So two triangles are similar. Remember, here's our similar sign to each other if they have three pairs of sides that are proportional to each other. That's why it's side, side, side. So it would have to have something like AB over RS because those are in the same spot. And you'd have to get BC over ST. And then the last one, AC over RT. If you set up those three proportions and they're the same, they're equivalent, then these triangles are similar. All right, the next rule is side, angle, side, which is what it sounds like. You have two sides and an angle, and the angle you have is going to be squished. So two triangles are similar, here's the symbol again, to each other if they have two pairs of congruent, or two pairs of sides that are proportional to each other and their included angle is equal. Okay, so right here, if you notice, I already have this included angle right here. So I have that part, that's the A. What I need to get is the side and the side, and if you notice, those sides squish the angle. And so I have to find sides that squish. And so here's one side that squishes, which is in the same place here. And then the other side that's going to squish it, let's go purple, is here. So those sides squish that angle. So the sides that have to be proportional are going to be XZ has to be over MP, and then XY over MN. So if I have an included angle, which is here, and two sets of proportional sides, and they're also similar. So there's side, side, side when all three are similar, and then side, angle, side where there's two proportional and then you squish an angle. So let's look at some examples. Let's see if they are similar or not. Here's the triangle. Ooh, I didn't mean to do that. Whoa, I got zoomed down. Hold on. Okay, so I got the view good. So what we're going to do is we're going to see if number one is similar to this triangle on the right, ABC, and if number two is similar to the triangle on the right. If you notice on the right, all I have is I have three sides, so I'm going to have to do that. Now, my triangles look a little different, so what I'm going to do is this is my biggest side. So my biggest side over my biggest side. I'm going to go to my next biggest side, which is 5. Which would go over 7, and then 2.5 over 4. And so now I'm going to actually take my calculator and I'm going to divide each of those things to see what I get. Okay, so 6 divided by 8 is 0.75. And if they're proportional, then 5 divided by 7 will also be 0.75, and it's not, it's 0.71. So we can stop because those two don't even equal each other. So this one is no. Okay, so now we're going to go to the next one. And the next one I'll choose green to look with. Same thing, I need to pick my biggest side, which is 6. Now, I can't tell what the biggest here is. Let's turn that into a decimal so that we know. And 12 divided by 5 is 2.4. So that's the biggest side. Then my next biggest side is 5. So that's going to go over 2. And then my next biggest side is 2.5, and that's going to go over 1. So now I have to divide each of those out. 6 divided by 2.4 is 2.5. 5 divided by 2 is also 2.5. And 2.5 divided by 1 is also 2.5. So this is a yes. So what we have to write is our similarity statement. So triangle, let's just do ABC is similar to triangle. Okay, so A was between the biggest side and the smallest side. So that's the same as, oops, R right here. Erase that other circle. And then I went across the longest side to get to B. So I need to go across the longest side, and I get to S. And then that leaves T. So triangle ABC is similar to triangle RST by side angle side. And so that's what you would write when they're similar. If they're not similar, it's nice. You just have to write now. All right, let's go to the next one. Let's verify that they're similar. Okay, so first thing I'm going to do is I'm going to try and draw a picture. Now, I don't draw pictures to scale. I just draw pictures for references so that I can see that things are in the same spot. So that means I'm going to draw them exactly the same. I'm not really going to turn them. I'm not going to make anything harder on myself than it needs to be. Now, even though they're supposed to be similar, it's okay if you write them as the exact same size. Okay, so now RS is 12, ST is 15, and S is 48. Okay, and then XY is 28, YZ is 35, and Y is 48. Now, if you look, it looks like it's going to be side, angle, side. Well, the angles right here, 48 and 48, those are equal. So I do have the A. But we need to check and see if we actually have those sides. So to check that, I'm going to do my proportion. So I'm going to do 12 over 28 because they're in the same spot. And then 15 over 35. So let's divide these out. 12 divided by 28 is 0.429 if I round. And then 15 divided by, 15 divided by 35 is also 0.429. So those are a yes. So we can say yes by side, angle, side. Okay. So remember, sides still have to be proportional, angles have to be congruent, and you just have to check things. And if they are, sides are proportional, angles are congruent, then you could say that they're similar by either side, angle, side, or side, side, side.